Today we are back on this Porsche 915 transaxle for Mac. And the goal for today is to try to get the selector forks installed and adjusted correctly. And I have some tooling to show you for that. And then I'm also going to set up the tools, also homemade, for the backlash adjustment. These aluminum rods are temporary tooling to work in conjunction with this plate. This plate is going to slip over the bearings and it's going to help me align the shift forks. Now, I didn't machine this plate myself, but I did all the drawings and sent it out to have someone else do it. But it is a nice part that is, I think, really important for setting up the shift rods. These are the shift rods and they do have some adjustability in them. So that's what we're trying to set up today. The shift fork adjustments are internal to the transmission, meaning when this housing goes on like this, you won't have access to those bolts to adjust it. So the best possible tool is actually the housing itself. A lot of guys will cut a big window out of this housing, and so the shift forks are secured through, these holes here and these holes here in the center section, and that's what keeps the shift forks parallel so you can adjust them. Rather than just cut this up, I thought I would do what everybody else does. And there's a piece of plastic you can order and it fits over these two upper bearings and it allows the shift forks to be supported up here. I ended up returning that piece. I thought it was junk. The holes are in the wrong place. It's plastic and it doesn't fit well with the bearings. So that's what a lot of people use, but it wasn't good enough. I'm just decided I was going to make my own plate. So see how this plate can move? It can wobble around because these bearings are really only supported on one side. So they have some freedom to move around a little bit. So this bolt has a precision surface on it and it's designed to go real tight into this bore. So that slips in just like that. And then up here, this locks in here like this. And there's it locks in three places. So even without tightening the bolts, this got a lot stiffer. But when these are tight, the plate is going to be in a great place. So now this is very firm and it happens to be directly above these studs here, which I can check. These rods are exactly perpendicular to the flange here where the center housing attaches. And it doesn't matter where you measure them. I've already checked them on all sides. So now these shafts are supported very well. They cannot move, and these are the holes here where the shifter selector rides in, along with these holes here. The idea is that this plate is going to hold those forks exactly parallel to the main shafts, and that's the way you can adjust it without having the housing on. But I'm going to take this apart again because I want to verify that these three holes are exactly on top of these three holes. And let me show you how I can do that using the other transmission. The other plates that you buy, they don't have the bearing races in there. It's just aluminum, and depending on the bearing roller tolerances, it may not fit. But if you actually use the races that belong with the bearings, it's a guaranteed fit. That's what I did there. And this is my other housing, and this one has already been repaired. This is the one that had the loose bearing bores. This has come back from machine shop services, and it's now better than new, with some steel sleeves and stuff in there. But what I'm doing is I've made these little pucks. These are little adapter pucks. So I machined these pucks to have the same diameter for the inside races versus the diameter of those. So what's going to happen with this plate is this plate is going to slip right over the top of this, and it's going to align the plate to the bores of the bearings. So now what I want to do is I want to make sure that these holes are directly on top of the holes that are here in the center housing. So I'm going to put this one in this hole because the detent pin is, the pin is still in there. So we're going to put that in there. So they're going in. I'm just kind of fighting with that detent pin just a little bit. So I'm just trying to get the detent plug out and I can't get it out. So I've just been, using brass punches and, clamping pliers. I can rotate it, but it won't come out. So I'm gonna resort to the welder and put a nut on the end of this. And that way there I can thread something in it and just pull it out. This is a good example of, it's easy to install, but really difficult to remove. So this should have been done all along. There it is. And sure enough, there's gunk behind here. So these are the things that you really should, remove. So rather than buy a new one, I'll probably just replate this one and reinstall it because now it's got a added benefit of easy to remove. And there's the tube. So I kind of used the tube to push it through, but now that's out. So now I can go back to what I was doing, which is trying to make sure these holes are lined up with these bores. Just put a tiny little bit of assembly lube on here because this is a polished surface, but I don't really want to scratch the bores. So that fits pretty tight, but goes in. That one goes in. Assembly lube. That's great. So now I can put the bolts on the ends, and these are the shoulder bolts. So it's a precision fit here. And it goes right in. So this plate is very secure. I know these holes are lined up. Yep, goes right in. So that's a huge relief that this plate works well. I made 2 of them because once it's on the CNC machine, my friend just said, let's make 2. So if there is a need for one of these, let me know. I'll sell it for like $100. Okay, I've got these brass shift forks cleaned up and ready to go. I've actually measured them and they're within limits. So I need to install them now onto the gear cluster. And I got the shift rods installed and kind of mocked up in place with this dongle piece. And this is how it all works together. But I really should have put these brass parts on while I put the cluster onto the housing, because I got to pull the gear cluster out again to basically slide these on together. There's no way for me to put these on after the fact. That's a little oversight on my end. I'm just covering the splines with a couple layers of this real thin packing tape, because I think that's enough to prevent the splines from cutting the seal. So just try not to have any wrinkles on there. And then on the outside of the tape, you just put a little bit of assembly lube so that seal can just go right over. See it poking in there? So it moves very free. I got some assembly lube on there, able to slide it around. Cleaned out this whole channel. And this whole channel here doesn't get a spring or anything. It's just an access to get that detent in there. But I did have to remove the plug from that side. This won't change the pinion depth. Once the shims are there, it doesn't hurt to untorque this and retorque it. It's not going to really mess anything up. So we'll just put it back the way it was. It won't affect the pinion depth. I got a little excited, getting the pinion depth finalized, and that's when I forgot to put in the forks. It's in the manual. I just didn't put all the pieces in. So with any luck, I can just move this aside and maybe get the forks in. So let's see what we can do here. There's one. That fork right there is in the way. Just having to remove this clamp bolt because the retainer is getting in the way of this guy. This needs to be up a little bit higher right there. And then I think it should go down one last time. Okay, I think now it's back down. I don't think that was the correct way to do this, but I am just trying to persevere here. Everything's back down how it should be. So let's get the nuts put on. We'll flip it over, take a look at that input shaft seal, and hopefully we didn't damage anything because it definitely slid through the shaft seal. So the tape did get pushed off a little bit. So that seal may be suspect. So probably what I'll have to do is leak check this with some oil in there and just have the transmission, pointing down and just verify that that seal is still doing its job. See how that socket fits right in there? Also, the manual says to go ahead and put these detents in with the springs because I think that's going to center the shaft. See how it vibrates up and down? The spring will help keep that shaft in its neutral place. So I think it does make sense because you don't want the shaft to be way out of whack because if you look down inside the hole, it's be hard to see, but there are little cuts in the shaft that need to interact with the detent and the spring. I haven't really cleaned these yet, but this is labeled 1, 2. This the spring detent and the nut or bolt there. So 1, 2 would be this one here on the right. And I'm just gonna make sure these slide in really well. I've already cleaned that bore, but let's make sure it's gonna go really easy. And it's just real easy going in and out. And then this has an aluminum washer on there, really should be replaced, but if it doesn't leak, it doesn't leak. This is something that's easy to change while it's in the car. So we'll just go finger tight on that. It's already influencing where the rod is. So that is exactly what we wanted. We want that spring to position the rod for us. This can still move around, but the rod is now positioned right where it should be. I had no problem getting the spring in this hole, but I had some problems on this one. I found out that the torpedo was not actually contacting the shaft. And that's because the shaft wasn't all the way in. It was sticking up proud up here. So there's actually a little sequence that I found that works in order to get both shafts at the same height. And then this has to be at the same height too. So luckily I took a pause on that. I'm gonna show you the procedure and kind of undo what I did, just so if you're going through this, you'll know how to get these two shafts at equal spots and how to make sure the detents are actually working correctly on the shafts, because that is like a lockout feature. So you can't put it in 2 gears at once. It's really important. I had to take all 3 of these bolts out here at the clamps because you need to be able to rotate the shafts more than usual in order to get these 2 detents to line up. And I was using this flashlight here in through the holes to see where the detents are in the shaft. So these little detents here on the shaft have to correspond with the height of this hole. And same is true for this one. Let me see if I can pull that one out a little bit. Yeah, it doesn't go high enough to be able to really see what's going on. So you'll have to take my word for it. There's a similar moon-shaped, kind of like there is right here. There's one down there. So here's the trick in order to get the assembly done right. You got to remember there's one of these between these two shafts. It's stuck here in the middle. It comes from that hole right there. So that prevents both shafts from just sliding in. So you have to use the flashlight and find the window. That's where the cutout is. And then you have to orient the window pointing to that shaft right there. So in this case, it happens to be, this part is pointing right towards the hole. And you have to hold it at the right distance. Then this shaft will go in. That allows the torpedo to go into this shaft partially, and then this upper one should be able to slide right down. And it's helpful to put these indents pointing that way as well. So we'll get that to slide up. And sometimes you need to tap it down just a little bit. There we go. And now I can feel it hit the torpedo, but remember, if I push this one up just at the right place, I think it's right there, that should allow the torpedo to go this way so this shaft can come all the way down. So I'm just going to give it a little bit of a tap. And now both shafts are all the way down at the same height. So now I have to get this shaft rotated about 90 degrees that way, but it no longer will go. Oh, there it goes. So you can see if this shaft is turned out of position, this will not turn. But if I orient it in the right position, it will turn. So it's just a game of getting these guys, you know, moving in the right place. This is how it should be. You can check it with this. That's about the right height there. And then this will be about the right height here. These just so happen to be even on top. The two shafts should be even here. And then when we look through here, you should see how this torpedo interacts with the springs. And that's what keeps the shaft from going up and down. So it's just a little lesson I had to learn the hard way, but thought I'd share it with you guys. The other way to know that it looks right is that each of these should be sticking out the exact same amount. Now we can go ahead and put the clamp bolts back in. So before we can adjust the shift forks, we have to torque the nuts on the back. So I'm putting on my sort of homemade tool that blocks the input shaft from spinning. It's really just a clutch disc with a big steel bar attached to it. So this is a big heavy stainless plate and it's attached to the clutch disc. It's clamped pretty tight up here and then it's bolted down here. And then to make sure this doesn't spin on me or fall off the table, I'm just going to strap this guy down to the table. Okay, the input shaft is 90 foot-pounds. See how it's starting to move? That's what I didn't want to happen. But you can't go too far. Okay, there's 90 on that, and then the pinion shaft is a little bit more. Okay, the pinion shaft is 175. I'm going to do this in 2 steps just so I get a feel for how much pressure they're put on it. 150 is probably enough for the purpose of doing the shift forks, because this is going to have to come apart again. Okay, that's 150. I'm going to leave it at 150, given it's a little precarious on here. That's good enough to get the stretch needed in the pinion shaft. It's not going to affect the shift forks that much. The very first thing to adjust is this 1-2 shift fork, and you can see how it's loose right now. Now, the manual tells you to make it so it's just a little bit past vertical. Turn the selector fork rod of first and second, that is this one, left in driving direction to stop, then turn slightly back until the unmachined flat inner surface is almost vertical. There is an unmachined vertical surface on the back of that. Do not turn it back beyond the middle point or all the way to the right stop. So it goes this far, this stop and this stop. And basically what they're saying is you want it to be almost parallel. And there happens to be a nice little rib here. Let me show you. Right there is the flat surface. And you can see this flat surface up here as well. I kind of moved that one out of the way for the moment being. But you don't want it to be here and you don't want it to be here. It says slightly below vertical. So looking at this rib right here, and I'll put a straight edge on it, I'll show you what I think the manual is saying, and then I'll show you another way to check it. So if I use this Allen wrench as a straight edge, try to get here so you can see. This is all the way over, and it says to go back not this way, but it says just a little bit less than vertical. So that's right about there. So if you look at the way the wrench is pointing and the way that the rib is pointing, it's slightly less than vertical. And it says don't go past center, leave it right there. If I put this main shift rod in, this dongle piece is what actually selects the gears. So you don't want it to conflict. So right now it's actually really close to touching. Probably there's not enough clearance. And this is why I like to do this vertical, because this rod is kind of in a relaxed position. It does wiggle up here, and I'd like to do something better on that next time. But the best I can do right now is just make sure there's enough clearance on this shift fork. So I'm going to back it up just a little bit. So that controls the rotation, but I also need to make sure this shift fork is in the center of its travel between first and second gear. So I'm going to use some pin gauges on there and make sure it's exactly in the middle, and then we can tighten the bolt. These pins are 1/1000ths bigger for every time you go over. So it's basically from 1/4 inch to 1/2 inch. So roughly the same diameters if you pick two adjacent ones. So I'm going to use these to wedge these between the gears and the slider, and that makes sure that everything is in the exact center. Slide that up. Yeah, so this is just getting it to go in there. These might be perfect. So now that each of these pins are locked in place, I have just a tiny bit of freedom here. I'm going to try to pin the other side just to get it a little bit closer. As you can see, the pins are on that side and on this side. And what that leaves me with is even a little bit less movement here on the adjuster. And that's just the distance between the shift fork, which is brass, and the steel slider. And that is a specified clearance there in the manual. So what I'm basically going to do is I'm going to split the difference. I'm going to go up and down and then just lock it in. I could put feeler gauges in there, but that's really splitting hairs at this point. It's getting a little bit better. Yeah, real close there. Now it's starting to clamp. So I'm going to one more little bit of feel right there. Hold it, clamp it. Now it's no longer sliding, so we can go ahead and tighten this down and just double check everything. I'll torque that in a minute, but I want to go back to this measurement and make sure that this guy is still in a good place. So once again, I'm up here, I'm wiggling this left and right and making sure that this does not crash into itself, and it's in a good spot here on the shift fork. So no matter what I do, when I wiggle this big shift rod back and forth, no matter what I do, I cannot get it to interfere with that. And I think that's the key. I can slide, this doesn't really wiggle. This will wiggle, but no matter what I do, I can't get it to interfere. The slider is actually bigger than the gear. So the only thing we can reference now is probably this part or this part of the dog teeth. So this pin is much too big. I think I have the right size pins now. So that centers it just on the lip there of the dog teeth. Now these are just perfect. This is 359 and 358. See how it just moves the dog teeth? It's just a little bit of drag right there. So I think if I can use this on both sides, I think I can just tighten the bolt just like that. There is a fair amount of float in this guy, but that's okay. The last thing is this bolt over here, which controls this guy. Before I completely took apart this transmission, I put a handle up here on the shift selector, and I was going through the gears, and I had noticed that when I turned between the 1-2 plane and the 3-4 plane, this rod would go up and down just a little bit. And I think that's due to the adjustment between these two shift forks. They were not exactly parallel. So when this went from one fork to the other, from one fork there to the other, it would cause the rod to go up and down. Remember, there's a pivot here. So what goes up here goes down here and vice versa. So normally there's a pivot. That's part of the housing. It's not here right now because the housing's missing. But basically the name of the game and the way the manual says is to make these two shift forks absolutely parallel. And then you also have to adjust the angle because under no circumstances should these two things make contact. In order for the gears to shift, it has to slide relative to each other. If they stick to each other or if they are rubbing on each other, that's going to affect the shifting too. So the manual says 2 to 3 millimeters clearance and then parallel. Here's another case of tools that are actually called parallels. That one's too big. I think this one's too small. So we'll use maybe this on its side and then the pin gauge on top of that. How about that? So now we're guaranteed that the forks are parallel. Now we just have to do that 2 to 3 millimeter, and I'll just do that by eye. Tighten the bolt. See how those forks are nice and parallel? That's what we want. And then from here, it's going to be a little hard to see the clearance there, but you have to take my word for it. It's clear. Now, under no circumstances can I wiggle these parts and make anything interfere. I'm trying. We'll go ahead and shift it into some gears and make sure they don't touch either, but it's impossible for them to interfere. And same with this guy. When this is in here, it can go between forks, but it's not going to make any contact with anything that is going to clash. Even at high angles here, no interference whatsoever. So you see now there's still no opportunity for this rod. Even if I push it in, I cannot make contact. It'll stop into the back there. That's normal. But it's nice and centered on the fork. Let's go to first gear. And then we can see it's not making any contact here. No matter what I do, wiggling, whatever angle I put it at, it will not collide or interfere. Let's check the 3-4. No clashing, no interference. Once again, wiggling the top here, trying to cause a problem, and it just has good spacing everywhere you go. Now that it's in fourth gear, I can try to shift it into either first or second simultaneously, and it shouldn't allow itself to do that. And that's what the detents are for. So I'm gonna not push too hard, but I'm gonna try to do something you would never do. Be 2 gears at one time. And that's out of the way. No. There's a hard stop on that. It will not go down or up. So it is impossible to put it into 2 gears at once. So this is the orientation that's going to be in the car. So let's just make sure that both of these sliders are still centered and that these two things are still parallel. These two pieces of steel fit really nice. No changes here. Even after I've shifted into a few different gears, it's right back to parallel. The slider is centered right between the 2 cuts in the dog teeth. So that's, like I said, within 1/1000th of an inch. The slider is right there in the middle. So last thing to do would be to torque these to spec. I'm not going to do it right this minute because I'm still afraid that I damaged the input seal, and if that's the case, I have to redo everything. Let's just put, a couple ounces in. And see what happens. Spin the input shaft, that's how it works, so. Okay, while I'm anxiously awaiting to see if it's leaking oil, so far it is not. So far there's no oil, but while we wait, I think it's worthwhile to go through and check the backlash. Previously, I had checked the preload with some feeler gauges here on the end, and I know the preload is not, it's insufficient. It needs to be more, but it's adequate enough to be able to check the backlash. There is a small amount of preload. It's just not according to spec. So I do have some new shims, but before I take everything apart again to put the new shims on, I want to know the backlash because the two are related. And I made some tools, and that's where I screw the dial indicator on. It's just a clamp, but it's a little welded tube with a bend and then a nut on the bottom. So let me put the dial indicator on it. It'll make more sense. So it's just a 6mm bolt. Basically just screw that down onto there. So now all we have to do is lock these 2 gear sets together up here. We can just use a big wood clamp. See how these are 2 clamped together? So this hub, which is bolted down to the pinion shaft, cannot turn. That's the key. You don't want this shaft to turn. And even though it's not ideal, there's no way it'll turn. It's digging into the wood. So now when I turn this, nothing internal is moving. But I can hear the backlash is pretty loose just by feel. So let's put the instruments on and see what we get. Just tighten this down a little bit. That doesn't need to be super tight. Just make sure there's enough room here in the gauge and make sure the gauge is on tight. That's clamped down correctly. Yep. So the gauge is very stable. That's why I welded that bracket on there. It should be fine. I'm almost out of travel on the gauge, but it looks like there's still enough. Okay, so now we zero the gauge to right there. And it's pretty stable. It's not moving much. Re-zero. I'm getting 10, 11, 12, 13. 13.5 thousandths. So like I thought, the backlash is way too high. 0.34 millimeters, that's way too much. So it should be half of that, which would be around 6 or 7 thousandths. And that would only be a movement of the needle of just like that far. So the backlash is completely out of spec. It's twice what it should be. This thing would scream like crazy if we ran it like this. And that's okay, because it's part of the adjustment. I know the preload needs to be increased and the backlash needs to be decreased. I'll use differential shims and I will move the whole carrier closer to the pinion shaft. That's going to make the gears fit tighter and it's going to reduce the backlash. I had to guess on the spacers because they're all new bearings, all new differential, all new housing, all new input shaft. Everything here is different. So the fact that it's this big doesn't really surprise me. Smells like gear oil, but it's not coming out. So that's great. I may have dodged a bullet there. I'm going to come back in the morning and see what happens, but fingers crossed, we don't have to take it apart again. That's huge. Even though I have the parts to set the differential with the shims on both the left and the right, it's a tedious process of putting shims on the left, putting shims on the right, double checking it, preload, backlash, all those things. It takes a lot of time. So I'm out of time right now. I can't do it. But maybe next week we'll get that part done. We can go ahead and put the gaskets on, the center housing, the tail, all that stuff. We're really getting close here. Thank you for bearing with me. I think I made some small errors in assembly. I think I made it a little harder than it needed to be, but I'm learning and having fun. So thanks for being here. See you next week.